An earthquake can occur at any time. Studying earthquakes will help you learn where they might occur and how to prepare for their hazards. Hi, and welcome back.
Earthquakes. What you'll learn. Explain how earthquakes are caused by a buildup of strain in Earth's crust. Compare and contrast primary, secondary, and surface waves. Recognize earthquake hazards and how to prepare for them. If you ever bent a stick slowly, you might have noticed that it changed shape but usually springs back to normal from when you stop bending it. If you continue to bend the stick, you can do it for only so long before it changes permanently. Rocks usually change shape or deform slowly over long periods of time. As they are strained, potential energy builds up in them. This energy is released suddenly by the action of rocks breaking and moving. Such breaking and the movement that follows causes vibration that move through rock or other earth materials. If they are large enough, these vibrations are felt as earthquakes. Types of fault. When a section of rock breaks, rocks on either side of the break along which rocks move might move as a result of elastic rebound. The surface of such a break along which rocks move is called a fault. Let's analyze three types of faults. When rocks are pulled apart under tension forces, normal faults form, as you can see in this drawing. Along a normal fault, rock above the fault moves down compared to rock below the fault. So here you can see that this piece of land moved down, and here we have the fault. So one apparently moved down. Compression forces squeeze rocks together like an accordion. Compression might cause rock above a fault to move on compared to rock below the fault. This movement forms reverse faults, as you can see in this picture. So apparently this piece of land moved upwards or above. And as illustrated in the next picture, rock experiencing shear forces can break to form a strike-slip fault. Shear forces cause rock on either side of a strike-slip fault to move past one another in opposite directions along Earth's surface. Making waves. Do you recall the last time you shouted for a friend to save you a seat on the bus? When you call out, energy was transmitted through the air to your friend, who interpreted the familiar sound of your voice as belonging to you. These sound waves were released by your vocal cords and were affected by your tongue and mouth. They travel outward through the air. Earthquakes also release waves. Earthquake waves are transmitted through materials in Earth and along Earth's surface. Earthquake waves are called seismic waves. Now, let's talk about earthquake focus and epicenter. And this drawing is going to help us understand. Movement along a fault releases strain energy. Strain energy is potential energy that builds up in rock when it's bent. When this potential energy is released, it moves outward from the fault in the form of seismic waves. So these red circles represent the seismic waves. The point inside Earth where this movement first occurs and energy is released is called the focus of an earthquake. So here, this represents the focus of an earthquake. That means that in this point, the movement starts. This is where everything started. Now, the point on Earth's surface, because remember that this that happens here, the focus is underground, way down. Now, the point on Earth's surface located directly above the earthquake focus is called the epicenter of the earthquake. So, here, the point that is directly on the Earth's surface is my epicenter. And I suppose you're very familiar with this term. On the news, when there is an earthquake, they can tell you the epicenter of the earthquake was on, and they give you a location. Now, type of seismic waves. Primary waves, also known as P waves, travel the fastest through rock material by causing particles in the rock to move back and forth or vibrate in the same direction as the waves are moving. Also, we have secondary waves, known as S waves. They move through rock material by causing particles in the rock to vibrate at right angles to the direction in which the waves are moving. P and S waves travel through Earth's interior. Studying them has revealed much information about Earth's interior. Earthquake measurement. Seismologists are scientists who study earthquakes and seismic waves. The instrument they use to obtain a record of seismic waves from all over the world is called seismograph, like the one you can see in the picture. The height of the lines traced on the paper is a measure of the energy released by the earthquake, also known as its magnitude. Now, how do scientists, or to be more specific, seismologists, find out where is the epicenter of an earthquake? Well, when seismic wave arrival times are recorded at a seismograph station, the distance from the station to the epicenter can be determined. The farther apart the arrival times for the different waves are, the farther away the earthquake epicenter is. This difference is shown in this graph. Here you have the P waves and the S waves. So these speeds are used to determine how close a seismograph station is to an earthquake. Now, after distance from at least 3 seismograph stations are determined, they are plotted as circles with radii equal to the distance on a map. So on this map, you can see here we have 3 stations, and now that they have the distance, they can represent it as a radii in the map. Now, the epicenter is the point at which the circles intersect. So this point here, when the 3 circles intersect, that is my epicenter of the earthquake. The Richter scale. Its magnitude is based on measurement of amplitudes of heights of seismic waves as recorded on seismograph. So the Richter scale can tell us a lot about an earthquake. For example, if it was 5, earthquake level 5, that means that it was moderate. So you can know a lot of information based on the Richter scale. Tsunamis. Most damage from an earthquake is caused by surface waves. Buildings can crack or fall down, elevated bridges and highways can collapse. However, people living near the seashore must protect themselves against another hazard from earthquakes. When an earthquake occurs on the ocean floor, the sudden movement pushes against the water, and powerful water waves are produced. These waves can travel outward from the earthquake thousands of kilometers in all directions. Predicting earthquakes. Imagine how many lives could be saved if only one time and location of a major earthquake could be predicted. Researchers try to predict earthquakes by noting changes that precede them. That way, if such changes are observed again, an earthquake warning can be issued. For example, movement along faults is monitored using a laser-equipped distance measuring device, like the one you can see in this photograph. changes in groundwater level, or in electrical properties of rocks under stress have been measured by some scientists. Now, a major problem is that no single change in Earth occurs for all earthquakes. Each earthquake is unique.
I hope you found this video useful. Thanks for watching, and until the next one, bye!